Welcome to this video on Chapter 4, which is on perimeter and area. So I'm going to begin with 4.1, which is perimeter. And so what is perimeter? So the perimeter of a closed figure is like the distance outside. So if you were to walk around it, that's the perimeter. So if I draw this square right here, and so the perimeter of this square is pretty simple. So let's say this is 4, this is 4, this is 4, and this is 4. The perimeter of this is just going to be 16 because 4 plus 4 plus 4 plus 4. It's very simple. And you can do this for a bunch of different shapes, circles, triangles, and so that's what I'm going to move on to right now, and I'm going to do a problem involving the perimeter of a triangle. Now, I took the liberty of drawing up problem 4.2 here, and so it asks us to find the perimeter of this triangle DEF. And so the way we're going to do this is you can recognize that this triangle is an isosceles triangle because it has two base angles that are equal. So this is an isosceles triangle, and we went over that last chapter. So what that means is that this side is equal to this side. So over here we have this side's equal to 8. And because it's just the perimeter of the triangle, it's just the length of the outside. So it's going to be 8 plus 8 plus 8 root 3. And then, so that's going to equal to 16 plus 8 root 3. And that's the perimeter. It's very simple. Now I'm going to move on to 4.2, which is on area. And so the area of an object is what's inside the object. So for the triangle, it's what's inside here. Now, for a triangle, the area is really simple. The area is equal to the base times the height over 2. But that's when there's 90 degrees, because you need the 90 degrees there. So for this, you just draw a line down from the very top. Then you draw a line down so you have 90 degrees there, and then you have 90 degrees there. So the way you're going to do this is, for this triangle, to find the area of all this, it would be the area of A, B, C is equal to AC, which is the base, see, AC is the base right there, times XB, which is the height, see, which is what this dotted line is, and it hits the base at a 90-degree angle. So it's perpendicular to the base, over 2. So that's the area of this triangle right here. So that's very simple, and that's how you find the area of a triangle, and I'll go over that in a problem right now. So here's the problem 4.9 from section 4.2. And so what they want us to do is they want us to find XW right here, which is the height of the triangle. If you're looking at it, this is the base. So we're going to find out the area of this triangle right here, triangle XYZ. So the way we're going to do that is you take 6 times 8, because if you look at it like this is the base right here, 6, and 8 can be the height. So 6 times 8 over 2, which is equal to 24. So now that we have the area of triangle X, Y, Z, now we can figure this out too, because you can look at it from many different ways. So now the area of X, Y, Z is equal to 24, and that's equal to XW times 10 over 2. So the reason this is because this is the same triangle no matter which way you look at it, whether this is the base or this is the base. So this area has to be the same though. So 24, which you get by using this as the base and this is the height, has to be the same area as this XW would be as the height, and then this ZY would be the base. So that area just has to be the same as 24. So the way you would do this is XW times 10, which is the base, over 2 is equal to 24. So then you have XW times 5 is equal to 24. Now you just divide by 5, so XW is equal to 24 over 5. And that's your answer right there. So that's fairly simple, and that's how you can find the area of a triangle. Now I'm going to move on to section 4.3 here, which is on same base slash same altitude. So what's important about this chapter is two things. One, if two triangles share an altitude, then the ratio of their areas is equal to the ratio of the bases which the altitude is drawn to. So this is useful with problems that have two triangles that have the same base along the same line. And the second thing is that, so if two triangles share base, then the ratio of their areas is equal to the ratio of the altitudes to that of the base. So I'm going to show you how to use these and explain them. So this is problem 4.12 in section 4.3. So what it wants us to do is it wants us to find the area of ADX. So we have the areas here. The area of ABX is 24, the area of CBX is 15, and the area of DXC is 10. So the way we're going to go about this is using those rules I just said. So since triangle ABX here shares an altitude with triangle CBX, then we can say that the ratio of their areas is equal to the ratio of their bases. So if I go down and write this out, AX, which is the base of triangle ABX, over CX, which is the base of triangle CBX, is equal to the area of ABX over the area of CX. So what that is equal to 24 over 15. And so you can simplify that down to 8 over 5. So that's the ratio of the areas between these two. So now you flip it, and because triangle AXD and CXD, they also share an altitude, and because the bases are the same as these two. So you can say that the area of ADX over the area of CDX is equal to AX over CX, which is equal to 8 over 5. Now, because the area of CDX is 10, it's going to be 10 over the area of ADX is equal to 8 over 5. So because 10 is just 5 multiplied by 2, you can just go 2 over 2. So the area of ADX is equal to 16 because that's 8 multiplied by 2. So that's the answer for 4.12, and that's how you use those two rules I talked about. And so that's all there is for chapter 4.